Hi everyone, this is Jeff Amboy and welcome once again to my YouTube channel. In this video, I will discuss the properties of ideal gases and solve some problems involving the application of relevant concepts. But before I begin my discussion, I'd like to give a shout out to all my students in physics this semester. They are second year electronics engineering students in Batangas State University. Hello sa inyo guys! Kumusta kayo? Sana nag-enjoy kayo habang nanonood ng mga lecture videos ko dito sa YouTube. Thank you for all the support and salamat din sa lahat ng mga instructors and profs na nagsishare din ng mga vids ko sa mga students nila. Ayan, napasalamatan ko na kayo. Maraming salamat po. Woohoo! But before we discuss the properties of ideal gases, let me introduce the concept of the state of a system. The state of a system refers to its conditions, which can be described completely by its properties. So the conditions of a given system refers to its state. And for us to describe the state of a system, we have to know its properties. The properties which are used to describe the state of a system are called state variables. So again, here is an important term that we will encounter in the succeeding discussions. State variables. Bakit sila tinawag na state variables? Because these are the variables that describe the state of a system. Now, what are the examples of state variables? Examples of state variables are the familiar macroscopic properties like pressure, temperature, and volume. Another example of state variable is internal energy. These are some of the properties that we will be using to describe the properties of an ideal gas. Now, moving on, let's discuss the macroscopic description of an ideal gas. How do we say that a gas is ideal? Of course, in real life, we only have real gases. However, under certain conditions, real gases may be modeled as ideal gases. So what is this condition that is necessary so that we can say that a real gas behaves like an ideal gas? We have to consider the pressure of the gas. Why? Because real gases at low pressures can be modeled as ideal gases. Ayan, kinakailangan pala mababa yung pressure ng gas para masabi natin na kahit siya ay isang real na gas, pwede mo siyang i-model as an ideal gas. However, gaano ba kababa ang pressure na ito? Para masabi natin na yung low pressure ay sufficiently low so that we can consider the gas to be an ideal gas. The standard atmospheric pressure, which is 1 atmosphere. Sulat natin dito ha. 1 atmosphere. This is the standard atmospheric pressure. This pressure can be considered as a low pressure. So kapag ang pressure na pinag-uusapan natin ay malapit sa standard atmospheric pressure, then that can be considered as low pressure. And kapag mababa ang pressure ng gas, yung kanyang density mababa din. No? Ideal gases have low densities and they are maintained at low pressures. Because if we pressurize the gas, magiging compact yun eh. The molecules would be closer to each other than they originally are. That's why the density of the gas will increase. So that means that the low pressure is a requirement so that the gas would have a low density. Now, if we have an equation that describes the state of an ideal gas, then such equation is called the equation of state. The equation of state of an ideal gas relates its properties, including its pressure, volume, temperature, and mass. So if you will remember, these properties are called the state variables of a system. So if we're talking about a gas, then these are the state variables that describe the gas. Another important property which is important in the study of ideal gases is the concept of the mole. The mole is a quantity which describes the amount of substance present. So if we're talking about the amount of substance, then how much a substance is contained in 1 mole of a substance? If we will consider a dozen always consists of 12 pieces. But in chemistry and in physics, 1 mole of any substance always consists of a definite amount of substance, which is equal to a certain physical constant called Avogadro's number. So if we have a sample of substance, 1 mole of that substance contains Avogadro's number of constituent particles. So what do we mean by these constituent particles? These particles can be atoms or molecules. For example, you have a sample of gold metal. So these gold metal are made of gold atoms. So in this case, it's proper to describe the constituent particles in terms of the atoms of gold. However, if you have a sample of oxygen gas, for example, it's more appropriate to describe the constituent particles as molecules. Why? Because oxygen gas exists in the form of molecules instead of atoms. Why? Because pre-existing oxygen gas always consists of 2 atoms of oxygen. So, the combination of these 2 atoms form a molecule of oxygen gas. So, in the case of an oxygen gas, it's more appropriate to use molecules than atoms if we are referring to the constituent particles that make up the oxygen gas. So now, if we are saying that 1 mole of any substance contains Avogadro's number of particles, then how many or how much is Avogadro's number? Okay, if you are already familiar with this, then Avogadro's number is equal to this number, 6.022 times 10 raised to 23. 1 mole of substance always consists of this amount of atoms or molecules. Sometimes, they can be ions. If we're talking about a sample of matter that possesses a net charge, then it's proper to describe the particles as ions rather than atoms or molecules. Once again, this is Avogadro's number, which is a constant in physics and chemistry. In most calculators, this is constant 24. Now, what if we are given the mass of the substance and we want to know the equivalent number of moles? To get the number of moles given the mass of the substance, we just divide the mass by the corresponding molar mass of that substance. So, once again, if you want to get the number of moles, you divide the mass, which is M, by the molar mass, which is capital letter M in this case. Small letter m is mass, capital letter M is molar mass. The molar mass is measured in grams per mole. So, tandaan natin ha, kapag ka molar mass, naka-grams per mole yan. Pero minsan, kapag ka ang tinatanong sa iyo ay atomic mass or molecular mass, ang mass na pinag-uusapan natin ay maliliit. At dahil yun ay nasa atomic or molecular level, kasi atomic mass or molecular mass, ang unit na ginagamit ay AMU. For example, what is the atomic mass of oxygen? The atomic mass of oxygen is 16. 16 AMU. How about its molar mass? The molar mass this time is 16 grams per mole. Why? Because we're talking about 1 mole of oxygen which consists of many particles. Kaya hindi pwede na AMU. Again, we use AMU for atomic or molecular masses. But for molar mass, we use grams. How about the molar mass of oxygen gas? For oxygen gas, again, that is O2. And because it consists of 2 atoms, then dapat imumultiply natin yan ng 2. So, ito ay magiging 32. So, ang molecular mass is 32 AMU. But the molar mass is 32 grams per mole. Okay? So, kung molar mass, 32 grams. Pero kung molecular mass, 32 AMU. Okay? So, I hope that's clear. Now, let's talk about the gas laws. So what are these gas laws? These are the laws that describe the behavior of gases. In this case, we will only consider ideal gases. Again, paano nga natin masasabi na ang isang real gas ay nagbe-behave na parang isang ideal gas? Kinakailangan ang kanyang pressure ay mababa at ang kanyang density mababa din. In most cases, the gases that are being used in problems in physics can be modeled as ideal gases. Even the air, which is at standard atmospheric pressure, that may be considered as an ideal gas. Now, let us consider a fixed amount of gas. So, kung fixed yung amount ng gas, constant yung number of moles. Now, what if we keep the temperature of that gas constant? Ayan, ginawa natin constant ang temperature. And this gas undergoes a process. Now, what are the variables that will change? Kung constant ang temperature and the number of moles, ang magbabago na lang dito is yung pressure at saka yung volume niya. So, ano ang mangyayari sa pressure ng gas kapag ang volume ay nag-increase? Or what if kinompress natin yung gas? No? Kung kinompress mo yung gas, magde-decrease yung volume niya, what will happen to its pressure? We can imagine a situation in which there is a balloon whose temperature is kept constant. If you compress that balloon, of course, its volume decreases. What happens to its pressure? Okay, you can imagine that the pressure inside the balloon would build up, right? So, pag kinompress mo ang balloon, liliit ang volume. Kung lumiit ang volume, tumaas naman ang pressure. So, ano ang relationship? We can then say that the pressure is inversely proportional to the volume of the gas. And because of that, makakagawa tayo ng isang equation mula dito. P is equal to K times 1 over V. Okay? So, tanggalin natin yung proportionality sign and let us introduce a proportionality constant. Kaya naging P is equal to K times 1 over V. Kapag yung equation minultiply ko both sides ng V, may makukuha ako na equation na ganito. P times V is equal to K. So, anong sinasabi nito? This means that if we keep the temperature of the gas constant, the product of the pressure and the volume remains the same. It doesn't change. Constant siya. That is why, if I have two conditions, condition 1 and condition 2, yung product ng P1V1 equal din sa product ng P2V2. And some of you might be familiar with this equation, no? This equation represents a law in physics which tells us that if the temperature of a fixed amount of gas is held constant, the pressure of the gas varies inversely with its volume. And this statement is called Boyles' law. Okay, so kung familiar kayo, yan yung Boyles' law. Yes, Boyles' law. The hottest law in physics. Why? Because it boils. If a process occurs at a constant temperature, then that process is called an isothermal process. Sulat natin, isothermal. Ayan. Next, this time, what if ang gawin nating constant ay ang pressure? Kapag constant ang pressure, ano naman ang tawag sa process? Ang tawag dyan is isobaric. No? Iso meaning equal. Baric referring to pressure. Equal pressure, same pressure, or constant pressure. Ngayon, kung constant ang pressure ng gas, ano naman mga variables ang magbabago? Magbabago ang volume at saka yung temperature. Kapag pinainit natin yung gas, halimbawa, yung balon uli, yung balon, ilagay mo dun sa initan, habang umiinit siya, of course, nag-i-increase yung kanyang temperature. What will happen to the balloon? We can imagine that the balloon expands, right? If the balloon's temperature increases at constant pressure, it will expand. Therefore, the volume increases as the temperature increases. So what relationship do we have here? We have a direct relationship. We say that if the pressure of a fixed amount of gas is held constant, then its volume varies directly with its temperature. To be more accurate, let's say absolute temperature. From this relationship, makakagawa tayo ng isa pang equation. V is equal to KT, kung saan yung K proportionality constant. And because of that, V over T must be equal to K. No? So this tells us that if the pressure of the gas is held constant, then the ratio of the volume to the temperature of the gas does not change. And once again, if we have two conditions, 1 and 2, then we can use ratio and proportion. V1 over T1 equals V2 over T2. Kung ito, P1V1 equals P2V2, ang tawag ay Boyles law, ano naman ang tawag dun sa law na nagsasabi sa atin na kapag ang gas, kung constant ang pressure niya, yung volume ay directly proportional to the temperature. Yan ang tinatawag natin na, can you guess? Yes, that's right. It's called Charles' law. Okay, so once again, let's state Charles' law. Charles' law states that if the pressure of a fixed amount of gas is held constant, its volume varies directly with its absolute temperature. And because of that, kapag nagko-compute tayo ng problems involving ideal gases, dapat yung temperature ay laging naka-kelvins. Okay? Why? Kasi sinasabi ng law, ang volume ay directly proportional sa absolute temperature. Tatandaang mabuti kapag nagsosolve ka ng problems involving ideal gases, dapat yung temperature lagi mong i-convert into kelvins. Kasi pag hindi ka nag-convert, magkakamali ang iyong sagot. Okay? Constant temperature, constant pressure. This time, gawin naman natin constant yung volume. Ano? So, kung constant ang volume ng gas, ano ang magbabago? This time, magbabago naman ang pressure at saka ang temperature. Anong magandang example dito? Consider a pressure cooker. Of course, yung pressure cooker, sa loob nun may laman, ano? Yung niluluto. Bukod sa niluluto, may gas sa loob nun, may hangin. And we know that the pressure cooker has a cover, no? Kung sa ay may lid at yun ay nakalock, then we can say that the volume of the gas, which is air, inside the pressure cooker remains the same. It doesn't change. Okay? At habang umiinit ang pressure cooker, dahil ng apoy, tumataas ang kanyang temperature. Anong masasabi natin sa pressure ng gas sa loob ng pressure cooker? No? Di ba kaya naluluto ng madali yung bulalo, for example, or mais na niluluto mo sa loob ng pressure cooker is that in addition to heat coming from the high temperature, nakakatulong din sa mabilisang pagluto yung pressure ng gas sa loob. Habang tumataas yung temperature, tumataas din ang pressure noong gas. Kaya siya tinawag na pressure cooker kasi malakas ang pressure ng hangin doon sa loob. So after maluto nung pagkain mo, hindi agad-agad binubuksan ang pressure cooker, no? Kasi baka mag-explode yun sa sobrang taas ng pressure. Kinakailangan, palamig-lamigin mo muna ng kaunti. Hayaan mong mag-subside ng kaunti ang temperature para yung pressure sa loob ay mag-decrease at pag siya ay binuksan mo, hindi magiging violent yung pagtalsik ng lid ng pressure cooker mo. Okay? So now we can summarize this using a relationship that the pressure is directly proportional to the temperature. Temperature. So sir, dito dapat absolute din? Yes, we say that the pressure is directly proportional to the absolute temperature of the gas. Pag tumaas ang temperature, tataas din ang pressure. So makakagawa tayo ng equation dyan kagaya nung kanina. Yes, itong volume, palitan mo lang ng P. Gawin mo lang P over T is equal to K. 'Di ba? So, this tells us that if the volume of a gas is held constant, then the ratio of the pressure to the temperature remains the same. It doesn't change. And if you have two conditions, 1 and 2, you can still use ratio and proportion to formulate this equation. P1 over T1 equals P2 over T2. Now, this equation may look familiar to you because you have already encountered this when you were in high school. Diba? Anong tawag dito sa equation na ito na nagsasabi sa atin na kapag ang volume ng isang ideal gas ay hindi nagbabago, yung pressure niya directly proportional sa kanyang temperature, ang tawag dyan ay, yes, that's right. You call it Gay-Lussac's law. O, di ba? Meron na tayong tatlong laws ngayon. Boyles law, Charles law, and Gay-Lussac's law. Now, what if yung pressure at saka temperature parehas kong gawing constant? No? Ano naman ang magbabago? Kung constant ang P at saka T, so dapat magbabago na ngayon yung V. Yes. And this time, magbabago na yung number of moles. So, constant ang pressure at saka ang temperature. Ano kaya ang mangyayari kapag nag-increase ang number of moles? Common sense will tell us na kapag pinadami mo yung gas, at hindi nagbabago ang pressure at temperature niya, of course, yung volume ng gas ay mag-i-increase. Diba? Kasi dumami yung gas. That's why we can say that if the pressure and the temperature of a gas are held constant, then the volume is directly proportional to the number of moles. And because of that, we can have this equation. V over N is equal to K. No? And from this, if we have two conditions, 1 and 2, V1 over N1 equals V2 over N2. So, anong tawag dito ngayon sa equation na ito? Na nagre-relate sa atin ng volume at saka number of moles. How do we call this equation? It is called, yes, that's right, napakagaling. Ang tawag dyan ay Avogadro's Law. O, di ba? So ngayon, meron na tayong 4 na laws na nagde-describe sa mga ideal gases. Sir, tanong, ano yun? Meron po ba tayong pwedeng gawin para ang 4 na laws na ito ay mapagsama-sama natin at masummarize in only one equation? Yes, actually there is. Pwede nating pagsamasamahin ang 4 na laws na ito in a single equation. Paano yun? Tingnan mo lang. Nasaan ba ang pressure sa lahat ng equation na ito? Okay, dalawang equations ang may pressure. This one and this one. Okay, parehas silang nasa numerator. How about the volume? Tatlong equations ang may volume. 1, 2, 3 at lahat sila ay nasa numerator, 'di ba? Tapos temperature nasaan? Ayun, ang temperature ay nasa ilalim. Okay? So, bukod sa temperature, dito sa huli meron tayong number of moles, yung N nasa ilalim din. So, paano natin yung gagawa ng equation? Eh di yung pressure daw, pag minultiply mo ng volume at i-divide natin ng temperature and the number of moles, then this must be equal to a certain constant K. No? So this equation is just a summary of these 4 laws. Okay? This equation gives us a summary of Boyle's law, Charles' law, Gay-Lussac's law, and Avogadro's law. No? P times V divided by T times N is equal to a certain constant K. Therefore, for an ideal gas, the product of the pressure and the volume divided by the product of the temperature, absolute temperature, and the number of moles does not change. Okay? So, sulat natin yan ha. Copy-paste lang natin yan sa kabilang slide. Okay? From the previous slide, we're able to come up with a single equation that summarizes the behavior of ideal gases. And this equation is PV over yung NT, pinagbaliktad ko lang kanina Tn, ngayon ginawa ko lang siyang NT para magandang tingnan. Okay? Is equal to K. Now, considering an ideal gas, pwede nating malaman yung value ng K experimentally. No? And it has been found out experimentally that this K has a value, no? It's actually a physical constant, no? Constant 'yan sa physics at sa chemistry. Yang K na 'yan, palitan natin kasi isa pala siyang constant sa physics. Lagay na natin yung constant na ginagamit which is R. So now, we have this equation. PV over NT is equal to R. O, di ba? Nare-realize mo na ba kung anong gusto kong tumbuking equation? Yes, okay. From this equation, nakuha natin yung sikat na equation ng ideal gas na PV equals nRT. Yes, that is where this equation came from. This equation is just a summary of the 4 individual laws that describe ideal gases na ipresent ko doon sa previous slide. And this popular equation is known as the ideal gas law. Okay? Ito na ngayon yung tinatawag na ideal gas law na tinatawag din natin na equation of state of an ideal gas. Why? Because it is an equation that gives us the state of the ideal gas. It consists of the state variables P, V, N, and T. Of course, R is not a variable, it's a constant. At anong tawag natin dito sa constant na R na ito? This R is called the universal gas constant. In SI units, ano ang value ng universal gas constant? In SI units, it has a value of 8.314 and the unit is joules per mole Kelvin. Okay? Sir, kailan natin gagamitin ang value ng R na ito? Kapag ka ang mga given quantities, ang mga units ay naka-SI. For example, ang pressure ay naka-Pascal, the volume is in cubic meters. Of course, the temperature must always be in kelvins. Okay? But there are times when a problem has the volume expressed in liters. And sometimes, the corresponding pressure is expressed in terms of atmospheres. So in the case that the pressure is in atmosphere and the volume is in liters, we use this value of R, 0.0821 liter atmosphere per mole Kelvin. Okay? Now, ang reminder is, kapag nagsosolve ka ng problem, dapat ang mga units ay consistent. No? So kung gusto mo na itong gamitin mo, then all units must be in SI units. But if you want to use this constant, then the units of pressure and volume should be atmosphere and liters respectively. That is why you also need to know how to convert from one unit to another, no? Yung mga unit ng pressure at saka unit ng volume. Kinakailangan alam mo kung paano i-convert. Aside from the universal gas constant, another important constant in thermodynamics is the Boltzmann constant. This Boltzmann constant is very important specifically in statistical thermodynamics. But although this is not statistical thermodynamics kasi classical thermodynamics yung dinidiscuss ko, I would like to introduce to you this constant. No? Ano ba itong Boltzmann constant na ito? Boltzmann constant is actually a constant which is derived from two other constants. At ito yung mga constants na na-discuss ko na sa previous slides. Dalawa lang naman yung constant na na-describe ko, di ba kanina? Yung Avogadro's number at saka universal gas constant. That's correct, no? Kapag dinivide natin yung R, no, yung universal gas constant, dinivide natin ang Avogadro's number, ang makukuha natin ay isa pang physical constant, ang tawag ay Boltzmann constant, whose value is 1.38 times 10 to the minus 23 joules per Kelvin. So, tandaan natin yung value niyan ha, 1.38 times 10 to the minus 23 joules per Kelvins. Now, balikan natin yung ideal gas law na nagsasabi na ang PV is equal to nRT. Ayan, ang PV daw ay nag-nRT. Okay. Now, here, N represents the number of moles, right? However, what if instead of the number of moles, we're given the number of atoms, no? Or the number of molecules, which is capital letter N. How do we get the number of moles if we are given the number of molecules or the number of atoms? Madali lang. Yung capital letter N, i-divide mo lang yan ng Avogadro's number. So that means yung N, kapag dinivide natin ng Avogadro's number, ang makukuha natin is small letter n, which is the number of moles. Yes. So, pwede natin itong i-rewrite, no? PV is equal to this capital letter N divided by Avogadro's number multiplied by R times T. But we know that this R, if we divide it by NA, would give us the Boltzmann constant, KB, right? Ayan. So, pwede pala nating isulat itong ideal gas law in terms of the Boltzmann constant. Yes. PV is equal to this N multiplied by R over NA, which is the Boltzmann constant K times T. Okay? So, here it is. This is the ideal gas law in terms of the Boltzmann constant. Now, ginagamit natin yung Boltzmann constant kapag ang given is the actual number of molecules of the gas. Or in the case of helium, kasi ang helium ay monatomic, no? So, hindi siya nag-exist as molecules, but rather atoms of helium. No? In the case of helium, N is the number of individual atoms. But for example, in the case of oxygen and nitrogen, which are both diatomic molecules, then this N is in molecules. Okay? Kapag molecules or atoms ang given, ang multiplier ay Boltzmann constant. Kapag naman number of moles ang given, ang multiplier ay universal gas constant. Now, let us have a concept check. No? A common material for cushioning objects in packages is made by trapping bubbles of air between sheets of plastic. Kapag ikaw ay nag-order sa Lazada, yung order mo darating na naka-bubble wrap. Bakit naka-bubble wrap yung parcel? Of course, para ma-prevent yung halimbawa pagkabasag or pagkasira ng item habang siya ay itinatravel, 'di ba? Sang-ayon sa question na ito, this material is more effective at keeping the contents of the package from moving around inside the package. Kailan daw mas effective yung paggamit ng bubble wrap? Kapag ba yan ay mainit, kapag malamig, or either hot or cold days? Okay? So, kailan ba mas effective ang paggamit ng bubble wrap? May effectivity pa pala yun. Yes. Bakit? Kasi kung i-consider natin yung bubble wrap, syempre yung mga bubbles na yan may labang hangin. And kapag mainit ang panahon, of course, mataas ang temperature, anong mangyayari dun sa hangin na nasa loob ng bubble? 'Di ba? Mag-expand yun. 'Di ba? At kapag malamig, mag-shrink naman siya. No? So, kailan mas effective na pambalot ng order mo ang bubble wrap kapag mainit or kapag malamig, no? Considering na siya ay nag-e-expand pag mainit, 'di ba? Mas tighter yung grip ng bubble wrap doon sa binabalot niya kapag mainit. Bakit? Kasi nag-expand yung gas, 'di ba? So kung mas tighter yung grip niya doon sa binabalot niya, then mas protected, mas maganda yung pagkakabalot. Why? Kasi kapag yan ay cold day, di kung malamig. Anong mangyayari sa gas? Mababa ang temperature. So, makokontract yung gas. Maglulusen yung pagkakabalot doon sa iyong parcel. Okay? Kaya sinasabi natin na mas effective yung bubble wrap kapag mainit ang panahon. Kasi nag-expand yung gas at mas tight yung pagkakabalot doon sa iyong order. O di ba? Pwede mong payuhan yung courier, sabihin mo sa kanya na, "Kuya, kapag magde-deliver ka, make sure na kainitan ha para mas safe." Yung order ko. Kasi nagiging tighter at lumulobo yung bubble wrap kapag mainit ang panahon. Charot lang. Okay, moving on. Let us solve a problem. Find the mass of a single hydrogen atom and a single oxygen molecule. Ayan. So since we are talking about the mass of a single atom, no? Napakaliit niyan. So dapat ang makukuha nating value ay napakaliit. If that value is expressed in grams or kilograms, dapat napakaliit nun kasi isang atom lang 'yan. Ito naman, kung oxygen, isang molecule, 'di ba? So paano natin ito gagawin? Para ka lang nagko-convert diyan, ano? So ang given is 1 atom, no? Sulat natin dito, 1 atom of hydrogen. Para lang tayo ditong nagko-convert ng unit, dapat i-multiply natin siya ng isang conversion factor. Ano? So ano ang pa-convert natin? Ang isang atom daw ng hydrogen, gusto mong malaman yung mass niya. So first, i-convert natin siya. Ano? Remember that in 1 mole of hydrogen, gaano karaming hydrogen atoms yon? Sulat natin dito ha. Sa isang mole ng hydrogen, how many hydrogen atoms are there? Of course, we know that it consists of an Avogadro's number of H atoms. So dahil dyan, magka-cancel na yung number of atoms at ang matitira yung nasa numerator, which is the number of moles. However, hindi natin gusto malaman yung number of moles. Gusto nating malaman is yung mass. Kaya, ano ang sunod nating pang-multiply? Ang sunod mong pang-multiply is yung molar mass. Okay? Para makuha mo yung mass. And we know that 1 mole of hydrogen is how many grams? Okay, 1 gram yon. Pero gawin natin mas eksakto, 1.008 grams. Ayan. Okay. So dito, magkakaroon ng cancellation yung number of moles. At ang matitirang unit is grams, which is yung hinahanap na mass dito. Okay? So kapag yan ay ating kinompute sa calcu, ang makukuha nating sagot ay 1.67 times 10 to the negative 24 grams. So as expected, napakaliit na mass yung nakuha natin. Kasi nga, isang atom lang yan. Biruin mo, naka-grams na, pero to the minus 24 pa yan. 'Di ba? Sobrang liit ng mass nun. Now, how about for a single oxygen molecule? Okay, yung 1 molecule ng oxygen, alam natin, yun ay 2 atoms ng oxygen, right? So, sulat natin dito, 1 molecule of O2. Now, ano ang ating multiplier? Kagaya pa rin ito. Okay, so 1 mole of O2, meaning, yan ay oxygen molecules. Gaano karami ang isang mole ng oxygen molecules? That's equal to Avogadro's number of O2 molecules. Next, anong sunod nating pang-multiply? Okay, kagaya pa rin nung kanina, imumultiply natin siya ng molar mass. Ano ba ang molar mass ng oxygen gas? So, since yan ay O2, 16 times 2, that's 32. So, ilagay natin dito, sa bawat isang mole ng oxygen gas, ilang grams? 32. Bakit? Kasi nga po, dalawa yun eh. 16 times 2. 32 grams of oxygen. Okay? So, magka-cancel na ngayon yung units, no? Yung molecules magka-cancel, yung number of moles magka-cancel, at ang matitirang unit is yung grams, which is yun yung unit na hinahanap. Kasi mass ang itinatanong sa problem. Okay? So, once again, with the use of a calculator, pwede nating malaman ang sagot. Pag sinolve mo yan sa calcu, ang makukuha mong sagot is 5.31 times 10 to the minus 23 grams. Okay? So, mas mabigat yung molecule ng oxygen gas kumpara sa isang atom ng hydrogen. Of course, syempre naman. Hydrogen yung lightest eh. Diba? Let us solve another problem. What is the volume of a container that holds exactly 1 mole of an ideal gas at standard temperature and pressure? Ano ba yung ibig sabihin ng standard temperature and pressure na STP? Ayan, kapag ka standard temperature, ang temperature ay 0 degrees Celsius at ang standard pressure ay 1 atmosphere. Okay? So, paano natin ito isosolve? Kapag nagsosolve ka ng problem at hindi mo pa alam agad ang gagawin, it's better to list down the given. Analyze the problem by breaking the problem into pieces. So, paano mo siya i-break into pieces? Ilista mo yung mga given. So, here we have exactly 1 mole. So, N is 1. We are given the number of moles. And the temperature is given. T is equal to 0 degrees Celsius. But we know, pag nag-solve ka ng problems involving ideal gases at may temperature, dapat i-convert mo lagi into kelvins. So, ito, 273 kelvins yan. Tinanggal ko na yung 0.15 kasi maliit lang naman siya. Next is the pressure. So, yung pressure ay given din 1 atmosphere, no? At the moment, dyan ka nagwi-withdraw. At the moment, ATM. Okay. Ang itinatanong ngayon ay volume. Diba? Okay. So, paano mo isosolve yan? Okay. Wala kang condition dito. Walang initial at final. Pero may given ka na N, T, at saka P. Hinahanap yung V. No? So, this will prompt you, may nagting sa utak mo. Diba? May, I have an idea. Diyan mo na-realize na ang gagamitin mo palang equation ay yung ideal gas law. Yes. PV is equal to nRT. Bakit? Kasi dito, isa na lang yung yung V. Ito yung hinahanap natin na V. And all the remaining parameters are given. Of course, this is a constant. So, to solve for V, we just write here N, nag-nRT, divided by the pressure. Okay. Sulat natin dito, ha? We have 1 mole. Tapos, ang R na gagamitin natin, nakadepende yan sa given. No? So, since ang pressure ay naka-atmosphere, ang gagamitin natin ay yung 0.0821. Okay. How about the temperature? 0 degrees or 273 kelvins. Tapos, i-divide natin yan ng pressure. 1 atmosphere daw. Ayan. So, pag ito'y kinalcue mo, no, sigurado ko ang makukuha mo dyang sagot is 22.4. Sir, anong unit? Okay. Since ang ginamit natin ay yung 0.0821, di ba ang unit niyan ay liter? Atmosphere per mole Kelvin. Consistent naman yung unit na given kasi nga naka-atmosphere tayo, di ba? 1 atmosphere. Ang makukuha mong unit is liters. So yan ay 22.4 liters. Okay? Actually, may tawag dyan sa value na yan eh. Yan ang tinatawag natin na molar volume, no? Bakit? Kasi kahit na anong ideal gas, basta nasa STP siya, ang volume niya ay laging eksakto. Ganito, 22.4 liters. Again, this is the volume occupied by 1 mole of any gas for as long as it is ideal. 1 mole of any ideal gas at STP. Okay, tandaan natin ha, 22.4 liters. Let us solve another problem. In an automobile engine, there is a mixture of air and vaporized gasoline. No, ayan. So meron tayong makina ng sasakyan dito, 'di ba? So sa loob daw ng cylinder, merong mixture ng hangin at saka vaporized gasoline. Kinokompress yan, no? Meron tayo ditong piston, di ba? Yung piston bababa, pag bumaba yung piston, makokompress yung hangin na may kasamang vaporized gasoline. Tapos, i-ignite siya. Ayan. According to this problem, a typical engine has a compression ratio of 9:1. Anong ibig sabihin yan? So, it means that if you compress the gas, then its new volume would be 1/9 of its initial volume. Kasi 9:1 yung ratio. The intake and the exhaust valves are closed. So, dahil dyan, walang hangin na papasok or lalabas. We can consider this as a closed system. The quantity of gas is constant. Now, what is the final temperature of the compressed gas if its initial temperature is 27 degrees Celsius? And the initial and final pressures are 1 atmosphere and 21.7 atmosphere respectively. Okay, so once again, kung hindi mo pa alam agad-agad kung anong gagawin, no? Anong magandang practice? Ilista mo muna ang mga given. So isulat natin dito ang mga given quantities, ano? Yung volume, of course, alam na natin yung initial volume, yung V1 is equal to VI, 'di ba? Tapos yung V2 ay equal sa kinompress mo. So, it will be 1/9 of the initial volume. Now, ano pa ang given? Bukod sa volume, may nabanggit siya na pressure. Ayan, ang P1 ay equal sa 1 atmosphere. Okay? Tapos, nung na-compress yung gas, syempre, tumaas ang pressure, no? Naging 21.7 atmospheres. Tapos, ang sabi, ang initial temperature niya daw, T1 is 27 degrees Celsius. Now, ang itinatanong dito is, ano ang kanyang final temperature? 'Di ba? So, before solving the problem, we can imagine that the temperature of the gas will increase. Bakit? Kasi, kinompress mo siya. 'Di ba? Tumaas ang pressure, anong mangyayari sa temperature? Mag-i-increase din yan. Okay? So, ano na ang temperature? O, pwede na natin yung isolve ngayon. And since nakita na natin dito na yan ay may condition, first at second, may pairing no? Hindi gagana yung ideal gas law. Dahil meron tayong volume, pressure, at saka temperature, lahat sila ay nagva-vary, di mula sa ideal gas law, kunin natin yung relationship ng tatlo. Ano ba ang relationship nila, di ba? PV over T is equal to K. 'Di ba? So, yan lang yung involved, no? Pressure, volume at saka temperature. So, galing din yan dun sa ideal gas law. Tinanggal lang natin yung N. Bakit? Kasi constant na yung N Closed yung system, 'di ba? Dahil diyan, kung meron tayong initial at final condition, pwede nating sabihin na P1 V1 over T1 must be equal to P2 V2 over T2. Okay? Since ang hinahanap natin ay T2, si Tito Suto, that T2 is equal to P2 V2. Sulat natin P2 V2 times T1 all over P1 times V1. Okay? Mag-substitute tayo dito. Ano ang given pressure? Ang given pressure, P2 is equal to 21.7. And how about V2? V2 is 1/9 of VI times TI. Okay, or T1. T1 is 27 degrees. But 27 degrees in kelvins, that's 300, right? 300 kelvins. Tapos, i-divide natin yan. Divide natin ang P1, V1. Ang P1 is 1 atmosphere. V1 is VI. Diba? Kaya magka-cancel dito yung VI. Yan. Now, pag kinompute natin yung T2, of course, gamit ang calculator, ang makukuha nating unit is kelvins. Diba? So, in kelvins, ang makukuha nating sagot is 723 kelvins. Ayan. So, since ang given ay naka-Celsius, 'di ba? Mas madaling imaginein yung naka-Celsius. Convert mo lang 'yan sa Celsius, 'di ba? 723 kelvins minusan mo ng 273, that will give you a value equal to 450 degrees Celsius. So, ganyan kainit ngayon yung gas na nasa loob ng cylinder, no? Mainit siya, no? That is the reason why umiinit yung makina, no? Bakit? Kasi mainit yung gas, no? Mainit yung gas na nasa loob niya. Of course, magkakaroon ng conduction, kaya yung metallic na makina mag-iinit din. That is the reason why nag-iinit ang makina ng sasakyan. Okay? Let us solve another problem. This time, a problem involving a scuba tank. An empty aluminum scuba tank contains 11 liters of air at 21 degrees Celsius and 1 atmosphere. So here, the word empty is enclosed in quotation marks to indicate that the tank is not really empty. Ang ibig sabihin lang ng empty is that hindi pa pressurized yung tank. And the air inside the tank has the same pressure as the pressure outside, which is the standard atmospheric pressure. Kaya sinabi niya na ayan, 1 atmosphere daw ang initial pressure. Now, when the tank is filled rapidly from a compressor, of course, lalamnan mo ng hangin yung scuba tank gamit ang isang compressor, kaya pag dumami ang hangin, ang temperature ay mag-i-increase. Magiging 42 degrees yan. And of course, the pressure inside would also increase kasi nga, dinagdagan mo siya ng hangin. Sabi niya, the gauge pressure is 2.1 times 10 to the 7 pascals. Tanong, ano daw mas ng air ang nadagdag? At dahil nagdagdag tayo ng hangin doon sa loob ng scuba tank, itinatanong ngayon gaano karami yung hangin na nadagdag. Sinasabi niya pa dito na air is about 78% nitrogen, 21% oxygen, and 1% miscellaneous. So pag kinumpute mo yung molar mass ng air, ang average molar mass is 28.8 grams per mole. Sir, paano nakuha yung 28.8 grams per mole na yan? Yung air kasi 78% nitrogen daw. So ang gawin mo dyan, 0.78 times the mass of nitrogen. Okay? Compute natin sa calcu. 0.78 times, ang mass ng nitrogen is 28 kasi N2 siya, 'di ba? Plus 0.21 times 32 kasi O2, yung oxygen gas mo. So, compute natin 'yan. Dito pa lang meron na tayong 28.56 at yung miscellaneous na 1%, syempre may mass din 'yon. Kapag dinagdag natin yun dito, aabot siya ng 28.8 grams per mole. Okay? So, this is the problem, no? Meron tayong scuba tank. No? Sino sa inyo ang ma-experience na mag-scuba diving? Di ba? Ako taga-tabing dagat. Mula pagkabata ko, nandito na ako nakatira sa tabing dagat at karamihan sa mga resort dito nag-o-offer ng scuba diving. Maraming scuba diving schools dito pero kahit kailan hindi pa ako nakapag-try mag-scuba diving. Ang try ko pa lang, scuba. Scuba sa CR pag naglilinis gamit ang scuba. Okay? But the word scuba, trivia lang to ha, but the word scuba is actually an acronym. Parang laser lang yan eh. Yung laser, light amplification by the stimulated emission of radiation. Now, yun namang scuba, ang ibig sabihin yan is self-contained underwater breathing apparatus. Okay? So, if you want to go scuba diving, punta lang kayo dito sa amin. Marami dito nga scuba diving schools. Makakakuha kayo ng discount pag meron kayong referral ko. Okay, isolve na natin yung problem. Kung itinatanong sa atin kung gaano karaming mass ang nadagdag, paano natin ito i-compute? Again, kagaya ng nabanggit ko kanina, if you don't know what to do, kasi maraming given, para malaman mo kung anong gagawin mo, ilist mo muna isa-isa yung mga given parameters. So, dito meron tayong volume, di ba? Initially, ang volume natin is 11 liters. Tapos, ang temperature initially, magkano? We have 21 degrees Celsius. And the pressure is initially 1 atmosphere. Tapos, nung nilagyan natin siya ng hangin, di ba? Ang temperature daw ay naging 42. So, na doble, di ba? 42 degrees Celsius. Tapos, yung pressure niya, P2, ay equal sa 2.1. Try natin dito, 2.1 times 10 to the 7 pascals. Pero, nabanggit niya na yan ay gauge pressure. Okay? Mamaya, ipapaliwanag ko kung bakit mahalaga yung term dito na gauge. So, nung nilagyan ba natin ng hangin, yung scuba tank, siya ba ay nag-increase ang volume? Di ba hindi naman? Kahit lagyan mo pa siya ng hangin, the volume of the tank will remain the same. Okay? So, yung V2 natin 11 liters pa din. So, pwede natin itong i-consider na isang constant volume process. Bakit? Kasi hindi naman nagbago yung volume from condition 1 to condition 2. 'Di ba? Ngayon, kumpleto yung details ng P, ng V at saka ng T. So, hindi mo magagamit yung P1 V1 over T1 equals P2 V2 over T2 kasi kompleto na yung details. So dito, anong gagamitin natin? Balik ka sa ideal gas law kasi kompleto pala yung PVT. No? So, kung kompleto ang PVT, masosolve natin yung N gamit ang ideal gas law. Okay, sulat ko dito ha. Yung ideal gas law na PV equals nRT, may makukuha tayong N. No? So, kuhanin natin yung N initially. Yung N1, 'di ba? Yan ay yung number of moles bago lagyan ng hangin yung tangke na equal sa P1 V1 over R times T1. Okay, ilagay natin dito. Initially, ang kanya daw pressure is 1 atmosphere. Okay, ilagay natin dito 1 atmosphere. Tapos, yung volume niya initially 11 liters. 'Di ba? So, since tayo ay naka-atmosphere at naka-liters, ano ang gagamitin kong unit ng R? Yung may liter at saka atmosphere, 'di ba? So yung 0.0821. Now, yung temperature naman, T1. Yung 21 degrees, kinakailangan i-convert mo yan into kelvins, 'di ba? So 21 plus 273, that's 294 kelvins. Okay, solve natin yan sa calculator. Fraction sign, 11 divided by 0.0821 times 294 equals, okay, meron tayong 0.4557. Lagay natin to ha, save natin to sa A. Yan, kasi gagamitin natin siya later. 0.4557. 0.4557 moles. Okay, now let us solve for N2. For N2, that's P2 V2 divided by R times T2. Let's substitute the values. Yung P2, yan yung ginagamit nung referee kapag ka may basket. P2. At yan din yung sunod sa 6, no? P2. Okay. Now, yung P2 na nabanggit dito, ang sabi niya gauge pressure daw siya. Bakit mahalaga yung term dito na gauge? Kasi, pag nagko-compute tayo ng problems involving ideal gases, hindi lamang temperature ang dapat naka-absolute value. Kinakailangan pati yung pressure din. Sir, ano po bang ibig sabihin ng absolute pressure? Ganito kasi yan. So, lagyan natin dito ng drawing. Okay? So, kung ito yung vacuum na zero ang pressure, meron tayong tinatawag dito na atmospheric pressure. P atmospheric. So, yung iyong measuring device, ang baseline nun ay atmospheric pressure. Okay? Atmospheric pressure siya. So, that means, itong measurement na ito ang baseline kasi siya ay gauge pressure. However, pag nako-compute tayo, dapat ang baseline natin is 0 para maging absolute siya. Kaya, yung absolute pressure natin, ito yon, absolute pressure, which is referenced from 0. Vacuum ang reference doon. The absolute pressure is equal to the atmospheric pressure, P atmospheric, plus the gauge pressure, PG. Okay? So, yun dapat ang ilalagay natin dito na P2. So, we know that this is the gauge pressure. Kinakailangan dagdagan natin siya ng atmospheric pressure. So, 2.1 times 10 raised to 7 Pascal yun. Ano ba ang standard atmospheric pressure? Para yung gauge pressure maging absolute. Remember that the standard atmospheric pressure is 101.325 pascals. Tapos, multiply natin ang V2. Okay. Now, since ito ay naka-pascal, dapat yung volume natin ay naka-cubic meters. However, this is 11 liters. Okay. Paano tayo mag-convert? Sa 1 cubic meter na volume, meron tayong 1,000 liters. Okay. Yan ang conversion factor. Now, yung 11 liters, divide mo lang ng 1,000. Magiging cubic meters na yon. So, magkakaroon tayo ng 0.011 cubic meters dito. Tapos, i-divide natin yan ng R times T2. Of course, R must be in SI. 8.314. Diba? And then, T2. Ang final temperature natin is 42 degrees Celsius. Pag kinonvert natin yan sa Kelvin, edi 42 plus 273, that's 315 kelvins. Okay? May makukumpita tayo ngayon ditong N2. So, using a calculator, compute natin yan. Fraction sign, then parenthesis, 2.1 times 10 to the 7 plus 101,325 times 0.011 divided by 8.314 times 315 equals, okay, so we have 88.63 moles. 88.63 moles. Okay. Kapag pinag-subtract natin ito, malalaman natin ngayon yung number of moles na nadagdag. No? The number of moles added to the scuba tank equals N2 minus N1. And since nakasave naman sa calculator yung kanina, okay, etong sagot natin ngayon, which is ANS, ma-minusan lang natin ang sagot kanina, which is alpha A. Makukuha na natin ngayon yung sagot, 88.17. So we have 88.17 moles of air added into the scuba tank. But this is not yet the final answer. Why? Kasi ang itinatanong, what mass of air was added? So therefore, we need to convert the number of moles into mass. How do we do that? We do that by using this given parameter, yung molar mass ng air, 28.8 grams per mole. So we convert 88.17 moles times sa bawat isang mole ng air, merong 28.8 grams. So magka-cancel yung moles, no? Pag nag-cancel yan, makukuha na natin yung sagot, 88.17. Ito na yon. Multiply lang natin ng 28.8 equals, ay! So, ang makukuha nating unit ay naka-grams. Kung masyadong malaki yan, gawin na lang natin kilograms. Ano? So, this is 2.54 approximately. No? 2.54 kilograms. So, that's it. No? We're now able to solve the problem. 2.5 kilos na hangin ang idinagdag doon sa scuba tank. Kaya, yung scuba tank bumibigat, no? Kasi may nadagdag na hangin sa kanya. 'Di ba? Amazing grace. Now, let us solve another problem. From the scuba tank, punta naman tayo sa isang spray can. A spray can containing a propellant gas at twice atmospheric pressure. Yan. 202 kPa daw yan. Sir, yung pressure na yan, walang nabanggit kung gauge or absolute. Anong gagawin ko? Kung walang nabanggit na gauge or absolute, by default, it's the absolute pressure. Okay? So, ang pressure daw ay 202 kilopascal and has a volume of 125 cubic centimeters at 22 degrees Celsius. Ito daw ay tinos into an open fire. Ay, nilagay mo sa apoy. Tapos, syempre, may apoy doon, mag-iinit siya, no? When the temperature of the gas in the can reaches 195 degrees, ano daw ang pressure sa loob ng can? Ayan. So, because the gas is being heated, its temperature increased up to 195 degrees. So, we can expect that the pressure would also increase, di ba? At ang itinatanong ngayon, ano yung panibagong pressure? So, that pressure should be higher than this. Kasi nga, ina-expect natin mag-i-increase ang pressure. We can assume that the change in the volume of the can is negligible. Okay. So, kasi nga naman, pag uminit yung can, mag-expand din yung lata. Pero, i-assume muna daw natin na negligible yung volume expansion ng lata. Ang i-consider lang natin is yung pag-expand ng gas, dahil hindi siya maka-expand, kasi nga, constant ang volume, mag-i-increase ang pressure. Diba? So, this problem can be modeled as a constant volume process. In a constant volume process, anong relationship ng pressure at saka temperature? Di ba direct? Kung direct yan, naka-divide, no? P1 over T1 equals P2 over T2. So, to solve for P2, we just multiply P1 and T2 and divide them by T1. So, substituting the values. Ano yung pressure? Initially, the pressure is 202 kilopascal. So, dahil kilo yan, times 10 to the 3. And T2. T2 is 195 degrees Celsius. So 195 plus 273 is 468 kelvins. Divided by T1. The initial temperature is 22 degrees. So 22 plus 273, that gives us 295 kelvins. Okay? So pwede na natin ngayon computein yung pangalawang pressure. 202 exponent 3 times 468 divided by 295, that gives us 320,000. So gawin na lang natin siyang naka-engineering prefix, 320.46. Okay? 320.46 kilo Pascal. So ito na ngayon ang final pressure doon sa loob ng can. At dahil mataas na yung pressure, pag pinataas mo pa ng pinataasan, posibleng mag-explode na yung spray can. Ano? Sa sobrang taas ng pressure. Kapag hindi na kayang i-hold nung strength nung metallic can yung pressure sa loob, it will eventually burst. Now, may twist ito. No? Kanina, hindi natin i-consider yung volume expansion ng lata. Pero sa totoong buhay, nag-expand din yan eh. No? Suppose that we include a volume change due to the thermal expansion of the steel can as the temperature increases. Thus, that alter our answer for the final pressure significantly. Ayan. Magbabago daw ba significantly yung pressure? So, dito, kinakailangan compute natin yung delta V nung can, which is made of steel. Diba? If you recall, from thermal expansion, what is the change in the volume of a metal when it is heated? That's equal to beta times VO times delta T, right? Now, we know that this metal is made of steel, okay? And because it's steel, we know it's alpha. But remember, beta is equal to 3 times alpha, no? So, multiply lang natin ng 3 yung alpha ng steel. Tanda pa natin yun. That's 11 times 10 to the minus 6. And then, VO is 125 cubic centimeters. Ito siya. And delta T. Delta T is 195 minus 22. That's 173. Diba? 173 degrees Celsius or Celsius degree. So now we can solve for the change in volume. 3 times 11 times 10 to the minus 6 times 125 times 173. That gives us 0.71. Ayan. 0.71. Ang unit nito ay the cubic centimeters. Okay. Tanong, ito kaya ay significant ang effect? Kuhanin natin yung percentage ha. Initially, ang kanyang volume, gawin nating VI over VF. Ano ba ang VI over VF? VI over VF is 125, no? Divided by itong 125, dadagdagan natin ngayon ng expansion na 0.71. Ilang percent yan? 125 divided by 125 plus 0.71. This gives us times 100 para maging percentage. Okay, 99.4. 99.4%. So that means that the initial volume is 99.4% ng final volume. Okay? So that means gaano karami yung nadagdag? Ibig sabihin, nadagdag lang yan ng 0.6%. Diba? Yun lang yung effect ng expansion ng lalagyan. Ang tanong, maa-alter kaya significantly? Parang hindi naman kasi 0.6% lang. Compute natin ha, ano ngayon ang final pressure. Okay? So para malaman mo ang final pressure, di dapat 99.4% lang yan nung initial pressure. Diba? What is 99.4%? Ayan. Divide lang natin to ng 100. Tapos i-multiply natin dun sa sagot kanina na magkano? 320.46 kilopascals. Okay. So, 318.65. Ayan. No? So, considering the volume expansion of the metal, meron tayong final pressure na 318.65 kilopascal. So, from 320.46, hindi naman masyadong nagbago, no? So there is no significant change in the pressure. Why? Because we can conclude that this change in volume is also insignificant. Naiintindihan po ba? So kung naiintindihan na yan, let's discuss a new topic about the molar heat capacity of ideal gases. What is molar heat capacity? Okay, heat capacity is related to specific heat. Okay? If you multiply the specific heat by the mass, you get the heat capacity. But molar heat capacity is something else. Ano? So the molar heat capacity is the amount of energy that is needed to raise the temperature of 1 mole. Okay? Per mole ang basis dito. Unlike nung specific heat na per unit mass. Dito, per mole. Okay? So, to raise the temperature of 1 mole of substance by 1 Celsius degree. Paano mo malalaman ngayon yung molar heat capacity? Kung alam mo ang kanyang specific heat, madali lang, no? Para malaman mo ang molar heat capacity, multiply mo lang yung specific heat ng molar mass ng gas. 'Di ba? So here, we will represent the molar heat capacity as capital letter C. Of course, we know that this capital letter M is the molar mass of the substance and this C is the specific heat of that substance as well. So, ano na ang unit ng molar heat capacity? Instead of joule per gram Celsius degree, magiging joule per mole ito kasi molar. Joule per mole Celsius degree or mole Kelvin. So, pwede na natin itong gamitin sa pagko-compute ng heat na na-absorb or na-release ng mga ideal gases. Paano? Okay. We may recall that Q is equal to M times C times delta T. So, dati mayroon tayong mass at mayroon tayong specific heat. But this time, ang meron tayo ay molar heat capacity, no? Which is naka-mole yung denominator niya. So, para matanggal yung mole sa denominator, yung M papalitan natin ng N. Kaya yung formula niya ay magiging NC delta T. Okay? So, we now have the formula for finding the heat added or released by an ideal gas which is equal to N times C, capital letter C, delta T. This is the number of moles and this is the molar heat capacity. Naiintindihan po ba? Yes. Okay. Now, one more thing. No? When an ideal gas undergoes a process from one state to another, that process could be constant pressure or constant volume or constant temperature. Okay? Pero huwag na nating isali yung constant temperature. Bakit? Kasi kung constant ang temperature, walang delta T. 'Di ba? I-consider na lang natin yung constant pressure at saka constant volume. O ano naman ngayon? Kapag constant pressure ang process, edi ang gagamitin mong C ay N times Cp delta T. Okay, sulat natin dito. Q is equal to N times Cp delta T. This is for constant pressure. Now, how about if the gas undergoes a constant volume process? Palitan natin. Gawin nating CV yan, no? Parang curriculum vitae. So, we use NCV delta T if the ideal gas undergoes a constant volume process. So, ano na ngayon ang tawag dito sa CP at saka CV? These are the molar specific heats at constant pressure and at constant volume respectively. Okay? And as a matter of fact, they are related. No? Anong relationship ng CP at saka ng CV? So, they are related by this equation. They are actually related to the universal gas constant. Pag pinag-minus mo yung CP at saka CV, equal yan sa universal gas constant. Okay? Now, kung ang gas ay monatomic, anong halimbawa niyan? Halimbawa ng mga monatomic gases is yung mga noble gases, helium, di ba? Neon, argon. Okay. So, for monatomic gases, the value of CP is 5 halves times R, while the value of CV is 3 halves times R. So, take note of this 5 halves R and 3 halves R. Next, how about for gases like oxygen, nitrogen, hydrogen, which are diatomic gases? Yun bang values ng CP at CV magbabago? Yes. Actually, ito gagawin mong CV. No? At yung CP magiging 7 halves. Ayan. CP is now 7 halves of R and CV is 5 halves of R. So kung napansin mo, CP is always greater than CV, no? Kanina yung CP na 5 halves naging CV ngayon. Okay? Parang may pattern siya 3, 5, 7, no? 3, 5, 7. Common yung 5. Tapos, ang lahat ng denominators nila 2. 'Di ba? So, pag pinag-minus natin itong dalawa, ang makukuha natin ay R. What if i-divide natin? May makukuha rin tayong quantity. Ang tawag ay ratio of specific hits. Okay? So, this ratio of specific hits is denoted by the Greek letter gamma. Sometimes, this gamma is called the adiabatic index. In our succeeding discussions, pag nakita nyo yung gamma na yan, yung gamma, ang tawag ay adiabatic index kung saan equal siya sa CP divided by CV. So, pag nag-compute tayo ngayon ng gamma ng mga monatomic gases, magiging 5/3 yan, di ba? 5/3, which is equal to 1.67, di ba? How about for diatomic gases? For diatomic gases, pag nag-compute tayo, 7/5, di ba? At ano ba ang 7/5? That's 1.4. And for air, the value of gamma is also 1.4. Sir, bakit po 1.4? Because we have learned in the previous slides that air is mainly nitrogen, 78%, at 21% nun ay oxygen, di ba? And both of these are diatomic gases. That's why air has a gamma equal to 1.4, which is the same as the gamma for diatomic gases. Now, here is a table of the molar heat capacities of several gases. Meron tayo ditong mga monatomic gases at diatomic gases and polyatomic gases. Pansinin mo ha, yung kanilang mga values dito pare-parehas halos. Ayan no, CP, no? Ano ba ang CP ng monatomic gases? Di ba yan ay 5 halves at ito naman ay 3 halves? Yes! Kaya yan, pare-parehas sila halos. Tapos ito naman yung gamma nila, 1.67 approximately. Or nagkakalapit lang. Kapag diatomic naman, ano nga ang CP? 7 halves ng R. At ang CV ay, eto, kukopyahin ko lang. Kaya yan, halos magkakagaya sila. Hindi nagkakalayo. Tapos yung CP minus CV nila, eto, di ba? Equal sa R. 8.3 something. Tapos yung kanilang gamma is 1.4. Now we have polyatomic gases. Dito na medyo nagkakaiba-iba sila. Medyo malayo ang pagitan. Ito, dalawa magkalapit. No? Pero ito, medyo malayo na siya. Okay? Now, sir, bakit wala dyan ang mga solids? May rule kasi tayo para sa mga solids. No? For elemental solids, the values of their molar specific heat approaches the value 3R. Anong ibig sabihin nun? Sa mga elemental solids daw, ang value daw niyan ay 3R. Doon nag-a-approach ang kanilang value ng C. So, 3 times, ano ba yung R? 8.314. So, for elemental solids, the value of the molar heat capacity is approximately 25. Lagay natin dito, 25 joules per mole Kelvin. Okay? Actually, may tawag dyan. Ang tawag dyan is the rule of Dulong. Yung mahabang isda. And, ito yung maliit, yung petit. Minsan, tinatawag siya na the Dulong Petit Law. Okay? So, pag narinig niyo yung Dulong Petit Law, ang sinasabi niya lang is, ang mga elemental solids, ang kanilang molar heat capacity ay nag-a-approach sa value equal sa 3R, which is approximately 25 joules per mole Kelvin. Okay? Daming trivia, no? Now, let us solve the last problem for this video. A cylinder contains 3 moles of helium gas at 300 kelvins. Helium. Di ba ang helium, monatomic yan? If the gas is heated at constant volume, ayan, constant volume daw. How much energy must be transferred by heat to the gas so that its temperature would increase to 500 degrees Celsius? Okay, compute natin yan ha. Yung unang Q, sir, bakit may una? Kasi may pangalawa. Mamaya na yung pangalawa. Yun munang una. So, since ito ay gas, ano nga ang formula ng kanilang Q? N and then C. Pero nabanggit dito, constant volume daw. So, CV. N, CV, delta T. Substitute natin. There are 3 moles of helium. And since helium is a monatomic gas, remember that its CV equals 3 halves of R. Diba? 3 halves of, ano yung R? 8.314. times delta T. From 300, naging 500 Kelvin siya. So, ang change ay 200 kelvins. Compute na natin. 3 times 3 is 9 divided by 2 times 8.314 times 200. Okay. The answer is, ayan, we have 7.5 approximately. Gawin na lang nating engineering. 7.5 times 10 to the 3 is kilo. So, 7.5 kilojoules. 7.5 kilojoules. Next, yung pangalawa, ang sabi niya, how much heat must be transferred to the gas at constant pressure? Kung constant pressure yan, yung Q2, gagawin nating N times Cp delta T. Hindi naman magbabago yung N. Ang magbabago lang is ito. Kasi yung Cp ng monatomic gas ay 5 halves ng R. At ang R ay 8.314 times 200. Okay, i-edit na lang natin yung kanina. 3 times 5 is 15. So, 50 na lang dito. 15 divided by 2 times 8.314 times 200. The answer is, ayan, we have 12.5. Okay, 12.5 approximately. 12.5 kilojoules. Okay, so from 7.5, nagkaroon tayo ngayon ng 12.5 kilojoules. So, anong conclusion? Ang conclusion is, kapag constant pressure ang process, mas maraming heat ang natatransfer. Kumpara kung constant volume, no? Hindi naman nagbago yung number of moles natin. And the conditions are the same. Yung temperature change, parehas lang din. Okay? So, you just have to practice solving problems and don't forget to always consider the conventions in solving problems involving ideal gases. Dapat ang temperature laging naka-kelvins at dapat yung ating pressure naka-absolute din, kagaya ng temperature. So kung gauge ang pressure, gawin mo siyang absolute, no, by adding the atmospheric pressure to the given gauge pressure. And one more thing, consistency sa unit. Kung lahat yan ay SI, dapat SI units. Kung gusto mong gumamit ng liters at atmosphere, dapat ang gagamitin mong R is yung 0.0821 para ang sagot nating makukuha is tama. Okay? So that ends our discussion for this topic. And if you like this video, don't forget to hit the like button and share this to your friends who are also studying engineering. Thank you for watching. Bye!